This is part 3 in a series of tests to help individuals pass the B1 exam, but I want to be clear, B1 is a residential building inspector. It's also for the residential plans examiner. You can pass both with this series. I have 2 tests uploaded right now. I'll get more in the future. This goes over chapters 5 and 6. Finishes up that second exam that I uploaded at catchsunlight.com/QFPE. If you haven't previously watched it, I recommend looking at part 1 and part 2 before you look at this, so it goes sequentially. But in any event, good luck to you. I'm going to go through, read the questions, and show you the code references and give applicable commentary where it's necessary.
Okay, let's start with problem 61 on this video. What is the minimum nominal ledger strip on a girder to support floor joists? Section R 502.6.2. 502.6.2 says joint framing joists framing into the side of a wood girder shall be supported by approved framing anchors or on ledger strips not less than nominal 2 inches by 2 inches. So 2 by 2 is the answer there. And I think in part 2 we covered the fact that bearing support needs to be at least 1.5 inches on wood. So that kind of substantiates that, is the actual dimensions of a 2 by 2 is 1.5. 62, 2 by 2s on 16-inch centers with a 20 PSF snow load and a 40 PSF live load with a roof width of 32 feet are allowed to cantilever past an exterior bearing wall out a maximum of how far? So let's look at table R502.3.3, parenthesis 1. I assume most of you probably have inspected or otherwise built structures where you have a cantilevered section extending out, such as a dining room area, window, that kind of thing. So that's what we're talking about, extending past your exterior wall. So this is what table R502.3.3, parenthesis 1 says on this subject. If you go through like we have in the past, look for the right table. So in this case, I mentioned floor live load. You have 40 PSF, you have roof live load, 20 PSF, you have a snow load of 20 PSF. The width of your structure is 32 feet wide. You're using 2 by 10s on 16-inch centers. You're allowed to cantilever out past that 21 inches per this table. So the answer on this is 21. Let's go ahead and select that. 63, joists exceeding a nominal size of 2 by 12 shall have bridging at intervals not exceeding what? So let's look at R502.7.1. R502.7.1. So what you have here at R502.7.1, joists exceeding a nominal 2 inches by 12 inches shall be supported laterally by solid blocking, bridging to joists at intervals not exceeding 8 feet. So the answer there is 8 feet in this case, 8 feet. All right, 64. Except at the ends, notches in solid lumber joists shall not exceed how much of the depth? Now this is a topic. There's going to be topics for notches, for holes. We're going to be talking about joists, bearing and non-bearing studs, rafters, etc. I guarantee that ICC will ask you something on the subject. So I'd suggest highlighting everything I have on these particular questions. It's going to help you. Let's look at R502.8.1. They're probably going to ask you at least one, maybe even more than that from this section itself. 502.8.1. 502.8.1. So notches and solid lumber joists, rafters, and beams shall not exceed 1/6 of the depth of the member. So, and there's some other rules here, but let's go ahead and put down 1/6 for now. Make that selection. Let's go ahead and roll down. Notches, 65. Notches on the ends of joists shall not exceed what depth of the member? So 502.8.1. So notches at the ends. So we're not talking just anywhere right now. We're not talking in the middle of something. We're talking about you know, at the ends where you're like putting something on top of a ledger plate or something. Notches at the ends of members shall not exceed 1/4 the depth of the member. So the answer there as far as notches on the ends is 1/4. All right, 66. The diameter of bored holes and floor joists and rafters shall not exceed what depth of the member? R502.8.1. Important section. All right, let's continue here. The tension side of members 4 inches or greater in nominal thickness shall not be notched. The diameter of holes bored or cut into members shall not exceed 1/3 the depth of the member. So it's 1/3 right here. So let's go ahead and select 1/3 from the list. 67. Holes in joists shall be no closer than how far from the top of the member. Once again, R502.8.1. So holes shall not be closer than 2 inches. Let's see, 2 inches to the top or bottom of the member. So it's right there. And here, let's read the bottom one. Where the member is notched, the hole shall not be closer than 2 inches. So both holes and notches, you can't be within 2 inches of the top of the beam, or any side of the member. Let's go to 68. Except for manufacturer's recommendations, notches and holes in engineering wood products are allowed. So we're talking about an engineering solution, like an engineering piece of wood, things like that. So it's going to be a little bit different. Let's look at 502.8.2. I want to be clear, we're not talking about normal studs. You're talking about something that has some engineering specs on it. So cuts, notches, and holes, board and trusses, structural composite lumbers, structural glue laminated members, cross-laminated timber, members or eye joists are prohibited. So the point is, any of those things we just read off in that section, you cannot, unless, like if you have like an eye joist or something, you have knockouts already there. What you can't do on these engineered pieces is just willy-nilly cut. There's specific calculations that go into them. So you're just about guaranteed to be asked that question in a test. So make sure you know that. All right, lumber used for floor sheathing with 24-inch spaced joists and diagonal placements must be what minimum thickness? So just picture this. You have 24-inch thickness spacing, and you take some old, I'm sure you've probably remodeled buildings or seen it, and you're at a diagonal. Well, what minimum thickness do you need? How would you know that? Let's go ahead and see this at 503.1. 503.1. Jump over here to 503.1. Table 503.1. Let's go ahead and look at that. Lumber sheathing. Maximum allowable spans for lumber used as floor sheathing shall conform to table 503.1. So if you look at it, if you're on 24-inch spacing and you are diagonal to the joist, the minimum thickness is 3/4 of an inch. So just remember that, 3/4 of an inch. Go ahead and select that. Let's jump over to 70. What is the maximum span for 32/16 rated sheathing without edge support for a roof? Table 503.2.1.1 parenthesis 1. Let's go ahead and jump over and take a look at that. So table R503.2.1.1 parenthesis 1 says the following. If you have 32/16, that's the span rating. You are, let's see, what are we doing? We are without edge support. There's 28 inches. That is the answer on this. That's what you're doing. Let's see. We are just going through. I want to make sure this is the roof area. Sheathing roof. Yeah, so we're roof right there. So that is 28 inches is what you're allowed to do on that. All right, 71. What is the maximum subfloor span for joist with sheathing rating at 32/16? So what is the maximum subfloor span? So let's take a look at that. 32/16, once again, table 503.2.1.1 parenthesis 1. So same section here as the former answer. We're at 32/16, and we are on floor joist, subfloor. You're allowed 16 inches right there. That's what it is. So 16 inches would be the answer on that. All right, 72. Species group 2, 3 sanded plywood on 16-inch joist centers can be what minimum thickness? So let's look at table R503.2.1.1 parenthesis 2 down here. And what you have are, let's see here, 16-inch joist centers. So spacing of joists, the identification set column shows 2-3, and you are allowed 5/8. That's what it comes to. Excuse me. Hold on a sec. Can be what minimum thickness? Oh, this should be 5/8. Okay, yeah, my mistake. So when I put down the answers, I think I copied it somewhere else. So yeah, so there's obviously a problem there. I probably won't fix it, but just keep in mind the answer is 5/8. Okay. And I want to be clear. Look, I'm doing this as a free service. Okay, it takes me quite a few hours to do this, and I'm doing it to help myself out too. I might as well, if I'm studying, I might as well go through and help you as well. So don't be too mad if I make little mistakes like that. We catch them in these videos. All right, 73. What is the minimum thickness of particle floor underlayment? The minimum thickness. 503.3.2. So R503.3.2. Right over here. Floor underlayment. Particle floor underlayment shall conform to that and shall be not less than 1/4 inch in thickness. Now that's, it really surprises me. The reality is, I've never worked with 1/4 inch particle board before. I don't know if you have, but it allows it. So anyway, let's go to 74. Particle board shall be installed, R503.3.3. Particle board underlayment shall be installed in accordance with the recommendations of the manufacturer. And I've mentioned this before. There's no specific sections in a lot of the I codes relative to installation of unique items. So they're going to ask, I guarantee at some point you're going to be asked to install something. Well, what do you install it per? The solution is manufacturer's instructions, and they're going to have that in the list of items. So just look for that. That's something that I guarantee they're going to ask. All right, let's go to 75. All of the following are required for the area within the foundation walls when pressure-treated wood floors are placed on the ground, except, let's go to R504.2. R504.2 says, the area within the foundation walls shall have all vegetation, topsoil, foreign materials removed. So what this is asking is, all the following are required within the foundation walls, except what? Sand. So it says remove all vegetation, remove all topsoil, remove all foreign material. Sand is the only thing that's not in that list that we just read from R504.2. All right, 76. A polyethylene sheet is required over the gravel base and under pressure preservative treated wood floors directly on the ground, which is lapped by 6-inch joints and is at least how thick? So how thick is your vapor retarder going to be underneath the pressure preservative treated wood floors? So let's look at a 504.2.2. 504.2.2, polyethylene sheeting of a minimum of 6 mil. There it is right there. So 6 mil shall be used in that situation. All right, cold form steel. Floor structural framing requires screws for steel to steel connections with a minimum edge distance of what? Little confusing. This is not a straightforward question, but I'll show you the reference for it. You can see it. 502.2.5. 502.2.5 says screws for steel to steel connections shall be installed with a minimum edge distance and center to center spacing of 1/2 inch. So the answer there would be 1/2 inch. All right, 78. The joist designation for cold form steel joints on a 19.2 inch center to center distance with a 30 PSF live load and 16 feet 11 inch span is table 505.3.2. Let's go ahead and look that up really quick. Table 505.3.2, right over here. So what you're looking at is this particular number here. It happens to be 800S16-68. Now in this case, I want to be clear. So the 139 questions here, I created them and then used a script to help me make the HTML. Obviously, there was a mistake here. It gave me 2 options, and neither of them apply there to this particular item. So I could go back and take a couple minutes and fix it. I probably won't, but just be aware that there is, it's not in the list. So just know where to look it up because that's a question that I highlighted as being previously asked. All right, splicing, 79. Splicing with cold form steel joints is allowed in what situation? R505.3.7. Let's look at R505.3.7. And that is 505.3.7. Joists and other structural members shall not be spliced without an approved design. So it says an approved design. It says it there, but if you look, I'll show you here in a little bit. Splicing these C-shapes inside tracks is a little bit different. Let's take a look at the next question, 80. What is the minimum thickness of a concrete slab on ground floor? So if you're dealing with concrete floors, what's the minimum thickness for a concrete slab on ground floor? Now this is a floor. We're not talking garage, things like that. But if you look at our 506.1, concrete slab on ground floors shall be a minimum of 3.5 inches thick. So 3.5 inches thick is the answer there. 81. On ground concrete floors is permitted to have compacted fill with depths not to exceed what? Let's go back to 506.1.2. 506, R506.1. 506.2.1. Yeah. There it is. All right, so the fill shall be compacted to a uniform support of the slab, and except where approved, the fill depth shall not exceed 24 inches. So you can't have 24 inches under your slab. All right, a vapor retarder, 82. A vapor retarder under a concrete on-ground floor is required to be how thick? So this is under concrete. It is a floor. How thick do you need to be? R506.2.3. What it says here is a minimum 10 mil vapor retarder right there. Now I want to tell you something that was interesting. I was at the most recent IRC committee hearings in Cleveland for the ICC conference, and this was one of the issues that came up. They wanted to change this back to like 6 mil or something. Because the argument was used, well, why go with 6 mil? And the argument was, well, what if you rip it or something like that, or misplace it during fill? I don't know. I don't think you need 10 mil, but kind of interesting. So there clearly is people in industry that don't want to see this there. It's a waste of time. Why do you have the 10 mil there? You don't need it. All right, 83. A vapor retarder is not required under a concrete slab that is used for what? Let's go ahead and look at R506.2.3, Exemption 1. Garages. So you need them, all your interior area. I put food storage room. I know people store things like food in a garage, so maybe it's not applicable, but the reality is all living area, habitable locations need to have a vapor barrier under them. All right, 84. Support is required for rebar when placed in a concrete slab to keep the rebar within what section of the slab? R506.2.4. 506.2.4 needs to be from the center to upper 1/3 of the slab for the duration of concrete placement. That's the answer. So upper third, centered upper third, excuse me. And let me just explain why. If you look at a neutral axis and any beam for bending purposes, if you have it, neutral is defined as right in the middle for a geometrically symmetrical beam. And we're modeling a concrete slab as a beam. But the neutral axis right in the middle, if you bend that, technically the neutral axis doesn't bend. But if you're up on the top part, which I would think would be I'd probably want it more on the bottom part. I don't know why they have it on the top part here, but in any event, what it does is that's the member that would feel the stress. If it's in the neutral right in the middle, bad. You can't do that. If it's too close to the top or bottom, it's going to spall out. So that's why they spec these things out. But it is kind of interesting the way this is worded. I don't know if I would have done that. All right, let's see. We are at 85. Utility grade studs are permitted to be used if not supporting more than a roof and ceiling and shall not exceed what center to center spacing. So the cheap utility studs can be used, but you cannot use them in a bearing wall. Let's go to R602.3.1. So over to chapter 6 now. Good deal. Let's jump over here. I got a few these guys to jump through first. All right, there we go. So R602.2, what it says, let's go to R602.3.1, 602.3.1 over here. All right, exception 1, utility grade studs shall not be spaced more than 16 inches on center and shall not support more than a roof and ceiling. So there you go, always 16-inch centers, that's where you're at. End joints in top plates shall not be offset by more than what? Okay, so when you do a load-bearing wall, you have a double top plate, right? You have to have them, you can't have the seam right lining up on top of each other. You have to have it offset a little bit. So what is that offset? So let's go to 602.3.2 to answer that question. 602.3.2, top plate. Wood stud walls shall be capped with a double top plate installed to provide overlapping at corners and intersections with bearing partitions. End joints and top plates shall be offset not less than 24 inches. So the answer there is 24 inches. Bam. All right, 87. Rafters shall bear within how many inches from a stud beneath them? Okay, here's the deal. What if your rafters on 24-inch centers, your wall that's supporting that exterior wall is on 16-inch centers? You're going to have the potential to be offset a little bit, okay? So the question is, how close does that rafter have to be to the load-bearing stud underneath it? There's a certain distance away. So let's take a look at that. 602.3.3, 602.3.3, bearing stud. Where joists, trusses, or rafters are spaced more than 16 inches on center and the bearing stud below are spaced 24 inches on center, such members shall bear within 5 inches. So the answer there from the code is 5 inches. All right, 88. The number of 8D common nails for fastening blocking between ceiling joists to the top plate is what? Let's go to table R602.3 parenthesis 1. 602.3 parenthesis 1. What it says, item number 1 here, blocking between ceiling joists, rafters or trusses to top plate or other framing below. If you're using 8D common nails, you need 3 of them. So 3 of them. Toenailed. You're toenailing them. So let's go ahead and do 3. That should be the answer there. Okay, 89. How many toe-nailed 16 box nails are required to fasten the top plate to a stud? Okay. R602.3 parenthesis 1. Table R602.3 parenthesis 1. How many nails if there's 16D? Let's see here. Okay, continued. There it is right there. So you have 16 top or bottom plate to stud. And you are, how are we applying these? Toenailed. So I say toenailed right there. The answer is 3. So the answer on that would be 3. Let's go ahead and select 3. 90. How many 8D common nails are required to toenail a joist to a sill? Table R602.3 parenthesis 1. So, okay, how many 8D are required to nail a joist to a sill? Joist to sill, right up here, item 22. Joist to sill, you're toenailing. How many 8D are required to toenail? There it is, toenail. And the answer is 3. You need 3 8D commons. So just take a look at these tables. They show you how to read them. I gave some examples for your benefit. Guarantee you're going to be asked about this. Guarantee it's going to come up. All right, 91. What is the center-to-center spacing for 8D common nails when fastening 3/4-inch plywood with intermediate supports? Table 602.3.1, parenthesis 1. So down here, item 32, if you have, what was 3/4-inch plywood? 3/4-inch plywood. What this section of this table says is wood structural panels for wood structural panel exterior wall sheathing to wall framing. So 3/4-inch, you are on 12-inch centers for those fasteners, and it tells you what fasteners you need to use for the 12-inch centers. And it varies depending on what kind of fasteners, whether you're using staples or whatever it happens to be. So let's just do that. 12 inches is the answer in this case. All right, 92. What is the spacing for 16-gauge staples that are 1 1/4 inches long with a 7/16 inch crown when fastening 1/2-inch fiberboard sheathing? Once again, 602.3 parenthesis 1. Let's jump over. So, cellulosic fiberboard, you're dealing with I said, what did I say? 1¼ inch down here, 1¼ inch long, 16 gauge staple with 7/16 inch crown. Spacing is 3 inches. So you need to be 3 inches there. All right. What is the maximum, I'm reading number 93 now. What is the maximum thickness of structural panels? Excuse me, what is the minimum thickness? So what is the minimum plywood thickness you can use if you're making a brace wall or something like that? Minimum thickness of a structural panel. R602.3, parenthesis 3. Let's see here. What do you got? R603. .2, 602.2.3, Sorry, I'm wasting your time here, mumbling to myself. There we are over here. So if you look at this, the minimum size is 3/8. So I'm on table R602.2, parenthesis 3. Minimum dimension they give you is 3/8. So 3/8 is what you'd use in that case, 3/8. All right, 94. What is the minimum structural panel span rating for 7/16 structural panel wall sheathing? Let's go to the same table, table 602.3, parenthesis 3. What is the minimum structural panel span rating for 7/16 inch structural panel wall sheathing? So let's go to that same table, table R602.3, parenthesis 3. So right here, you're looking at 7/16 inch panel thickness. Your minimum wood structural panel span rating is 24/16. So it's actually 24/16 is what you'd use. All right, 95. Wood 2x6 studs supporting 2 stories and a roof are required to have what maximum center to center distance? You will get a lot of questions potentially from this table. I suggest highlighting it. Look at my highlights and do accordingly. Table R602.3, parenthesis 5. So if we take a look at this, we're looking at 2x6s, and we're supporting 2 stories above it. So in this case, you have 2 stories and a roof, 2 stories and a roof, and you're allowed to be on 16-inch centers as a maximum. You can't go more than 16-inch centers there. So hit 16-inch. Let's go to 96. What is the maximum center-to-center spacing of 2x4 wood studs supporting only a roof ceiling assembly? So if I have 2x4s only supporting a roof, let's go to this table, R602.3, parenthesis 5, and we have 2x4s over here on the far left column. And you can see from this image, it gives you these nice pictographs to help you figure this out. But it's only supporting the roof and ceiling member. You're allowed to have 24 inches. And as always, go ahead and read the footnotes. It doesn't apply in this case, but always read the footnotes when you're doing the test. It's not going to be as clear-cut as you think. So the answer is 24 inches there. All right, with the exception of cleats, how many wood studs are necessary at corners? So when you're framing up a corner, how many studs at a minimum do you need? Figure 602.3, parenthesis 2. Table 602.3, parenthesis 2. 602.3, parenthesis 2. Just bear with me as I hunt this down. Actually, it's figure 602.2.3, parenthesis 2. A third stud and or partition intersection backing studs shall be permitted to be omitted through the use of wood-backed cleats. So if you don't have cleats, the number, just look at these figures, the number is always going to be 3 studs at your corner. Otherwise, it'd be kind of challenging to get your sheetrock into place. All right, let's go down to 98. Interior non-bearing walls shall be permitted to be constructed with 2x3 studs spaced on what distance? So let's go, there's actually a few here, and this is complicated because there's 2 different answers you could use if you're ever asked by an AHJ. Let's go to table, let's see. Well, first off, let's see here. Let's go to 602.5. So 602.5 is called out. 602.5 says interior non-bearing walls shall be permitted to be constructed with 2-inch by 3-inch studs spaced 24 inches on center. So see, it says 24 inches there. But you got a problem here. Because if you go and look at table R602.3, parenthesis 5, so you have a conflict here. If you go to the second reference, it's table R602.3, parenthesis 5. If you take a look at 2x3 studs, non-bearing walls over here, it's always 16 inches. So you have a dichotomy between 602.5 and this table. So the question is, what do you do? I don't know. I certainly would go to the more conservative 16 if I was building. And if you look at this other reference in this problem, R102.1, I'm not going to take the time to look it up, but it kind of alludes to the fact that you should always go to the more specific, which could be interpreted as more conservative measurement. So if you go, we want to save money sometimes, studs are expensive. If you want to go on 24 inches, you frame something up on the interior like a family room basement wall or something, you know, you could always point to this that section I just pointed to, R602.5. I don't know the deal. Kind of funky. All right, let's go to 99. A stud in an exterior wall shall not be cut to a depth exceeding what percent of its depth? So R602.6.1, parenthesis 1. So let's jump over to R602.6. R602.6. Okay, let's go over to R602.6.1. 602.6.1 right here. Now I want to be clear about this too. Now keep in mind what we're talking about here. These are studs. These are not joists or rafters, so they're a little bit different. But what it says is notching. A stud in exterior wall or bearing partition shall not be cut or notched to a depth exceeding 25% of its depth. So you can't notch it, a load-bearing wall, more than 25%. I always get confused. I have notes pointing back between the notch section and the hole section, between floor joists and studs. It just helps me navigate the code, so I'd recommend that. But let's go to problem 100. A stud in a non-bearing, non-exterior wall is permitted to have a notch of up to what percent of its depth? R602.6.1. So R602.6 and parenthesis 1 here. Studs in non-bearing partitions shall not be notched to a depth exceeding 40%. So if it's non-bearing, it's 40%. 101. The diameter of a bored hole in a stud shall not exceed what percent of the stud depth? R602.6.2. So parenthesis 1, parenthesis 2. Boring. So let's go here. It's R602.6, parenthesis 2. Boring. The diameter of bored holes in studs shall not exceed 60% of the stud depth in the edge of the hole. And I'll read the next one because it covers the next problem. It also shall not be less than 5/8 inch from the edge of the stud. So right there, it gave you the percentage. The percentage here is 60%. So you can't have a hole more than 60% of the size of your stud. So picture a 2x4 with a 2-inch piece of ABS going through it. I mean, that would be just at the threshold if you run the numbers. All right, 102, we already read the code reference, R602.6, parenthesis 2, but let's read it. A bored hole in a stud shall be no closer to the edge of a member than what distance? We know it's 5/8. That's what we just read. All right, 103. When notching a top plate on a load-bearing wall by more than 50% to support piping, a galvanized metal tie not less than 16 gauge and 1.5-inch width shall be fastened across the plate, with each end having not less than how many 10D nails? So obviously, if you're running like a vent line or something, you got to cut into your top plate. And how are you going to manage that? So this gives you the instructions on how to do it. Take a 1.5-inch wide minimum width and go ahead and put it in, but how many nails do you have to have? And this is very prescriptive. It actually tells you the type of nails and how many you need. 602.6.1. Let's go ahead and read that. 602.6.1 right here. Where notching of the top plate by more than 50% of its width, a galvanized metal tie not less than 16 gauge, 1.5 inches side on the opening with not less than 8 10D nails having a minimum length of blah, blah, blah at each side. So you need 8 at each side. So that strip, I need 8 here to cover that notched location. So just keep that in mind. It's very prescriptive. All right, 104. No, we're on 104 now. Double studs are necessary if more than what percent of a load-bearing wall is notched. So, honestly, I think we've all framed. You got to notch. What happens when you notch a little bit too much? So let's look at figure 602.6.1, or parenthesis 1. That's right. So figure 602.6, parenthesis 1.
If a hole is between 40% and 60% of stud depth, then stud must be doubled and no more than 2 successive studs are doubled and not bored. So 60% is the magic number there in this case. All right, 105. What is the minimum sized header required in a non-bearing wall? So if you're doing a non-bearing wall, let's say you're on the gable side, you have a truss building, something like that, you're putting a header in for a window, you don't have to follow the header tables for that. What you need to do is recognize there's no load on that, so you can get away with something else here, and it gives you the span and stuff. 602.7.4, non-bearing walls. Load-bearing headers are not required in interior or exterior non-bearing walls. A single flat 2-inch by 4-inch member shall be permitted to be used as a header in interior or exterior non-bearing walls for openings up to 8 feet. So it's quite an allowance there that you're permitted. And I've actually inspected homes where people have used sized headers in non-bearing areas, and I'm thinking, oh man, you just wasted a lot of money for nothing, but whatever. All right, 106. Cripple walls more than 4 feet in height shall be framed of studs having the size required for what? Now, this is what I mean by this. So we looked before at the table with the nice pictographs that showed, you know, single-story, 2-story, 3-story structures and what size studs you need under it. What this is saying is if you have like a cripple wall on top of like a partial foundation for like a walkout basement, let's say, and the stud length there for that cripple wall is under 4 feet, you don't have to size it as though it's supporting, you know, everything above it. I guess you basically can size it based upon the size above. But let me read the actual code to show how that says. So if you're more, we're looking at it if you're more, 4 feet's the cutoff. So let's 602.9. 602.9, cripple walls. Foundation cripple walls shall be framed of studs not smaller than the studding above. Where exceeding 4 feet in height, such walls shall be framed of studs having the size required for an additional story. So that's how you figure that out. So an additional story is the answer there. Let's read the next one. All right, 107, a Hemfer header that supports a span of 5 feet 3 inches in an area with a 70 PSF ground snow load. That's a beefy snow load. That supports only a roof and ceiling with a building width of 24 feet. Needs to be at least what? Okay, so first off, 5 feet 3 inches, right? We already know anything above 4 feet needs to be double studded, right? So looking through the answers, the first two are obviously not correct. So that helps us with that solution. Let's look at table R 602.7 parenthesis 1 for the solution. 602.7. 602.7. Now you need to know how to read these tables, okay? These are really important tables to understand how to read. So know this. But let's go ahead and take a look at what we have here. Ground snow load. So look at the ground snow load. We spec'd out 70 PSF. Let's see. It's only supporting a roof and ceiling within a building. So we have a roof and ceiling section here. We are dealing with a width of 24 feet. So the structural width is 24 feet. And let's see. The answer is 5 feet 3 inches right there. So, 5 feet 3 inches. Let's go back from 5 feet 3. It's 2 2x10s. So 5'3" was in the problem description. The answer is 2 2x10s. So what you need there are 2 2x10s to solve that issue. That's how you read that. All right. Jack studs. Now jack studs get a little tricky, whether you need 1 or 2 or any. And there is some digressing information, which I'm not going to get into. I think I got into my original video, which is dated, I don't know, 4 months before this one, which is it's a 2-hour painfully boring video. I don't know if you want to watch that or not, but if you do, I do talk about it. Here I'm not going to. So how many jack studs are required for the girder in the previous question? So we just talked previously, that table, R602.7 parenthesis 1. We had the 5'3" and all the other stuff that I already went through. How many jack studs do you need? Now let me show you how you find that. So if you look, what you have here, 5'3", we had the 2 2x10s, 70 PSF snow load, NJ is number of jack studs. And if you look right there, it's 2. So each side you need 2 jack studs. I know a lot of people
are used to just framing with one, but if you have heavier situations, heavier loads, you need 2 jack studs on each side of that girder. All right, a 30 PSF ground snow load and a 24-foot wide structure with a 2x4 girder. So you're using 2 2x4s together, supporting only a roof and a ceiling. What span are you allowed to have with 2 2x4s? Let's take a look. 602.7, parenthesis 1. So we're going to go back to this section again. We are looking for supporting only a roof and a ceiling. Only a roof and a ceiling. You have 2 2x4s right here. You have a 24-foot wide structure and a 30 PSF snow load right there. The answer is 3 feet 1 inches there. So that's how you use that table. Really important to know that. I guarantee you're going to be asked a question from that table. So know how we just looked those up. All right, 110. Braced wall panels shall not have what? I don't know. Let's find out. 602.10.2. So let's look up 602.10.2. All right, right here. Braced wall panels shall be full height sections of wall that shall not have vertical or horizontal offsets. That's the answer. And it probably is obvious if you just look at it. It kind of makes sense. But all right, 111. Lead-in bracing. Using 1x4 wood with 16-inch stud spacing can be set at what angle? So if you have kind of a structural support, you don't see this used a lot. At least I don't. Maybe you do. But if you have a 1x4, what angle? So like, I don't know how to describe it. So you have this base, notched in. What does the angle have to be? There's a certain threshold, and what is the angle? It's a range. I'm trying to read this. Maybe it's maximum or minimum. Okay, with 16-inch stud spacing can be set at what angle? Okay, so let's take a look at this R602.table. Table R602.10.4. Lead-in bracing. So what you have here, lead-in bracing, 1x4, and you can see there's an angle. It needs to be 45 to 60 degree angles right there. So between 45 and 60, which of these are going to work, right? 35 is not going to work, 40 is not going to work, 50 works, 65 doesn't work. So it's within that range of 45 to 60. 50 degrees is the only one that works. All right, what types of mortar are allowed to be used for grout in masonry construction? So you'd have different types. If you're on the job site, I mean, you could be anal and look at the bags of mortar, or whatever they're using, but there's actually a spec for it. R606.2.12. Let's look at R606. Jump over here a ways. As I go, I'm just going to let you see some of my notes because there might be some other stuff here. I don't think there's a lot here. Okay, we're going to 606. Let's see. I guess I don't have anything here. Bam, bam. There we go. Okay, 606. 606.2.12 right here. Grout shall consist of these things. Type M or type S mortar to which sufficient water has been added to produce pouring consistency shall be permitted to be used as grout. So mortar of type M or S is what it comes down to. All right, 113. The minimum thickness of head and bed joints in masonry construction, except for the starting course over the foundation. So when you're doing masonry construction, how much mortar are you using bedding in? Let's look at R606.3.1. R606.3.1, and we are right here. So I'm going to read this whole thing because it answers a couple of questions that we're about to look at. Unless otherwise required or indicated on the project drawings, head and bed joints shall be 3/8 inch thick, except that the thickness of the bed joint of the starting course placed over foundations shall be not less than 1/4 inch. Now I want to point something out else we're going to ask this here shortly. Look at this. This is your tolerance. You have a bed joint tolerance of +1/8, a head joint of -1/4, and collar joints of -1/4. So if you're looking for like a maximum or a minimum, you got to apply the tolerance. These are more nominal here in 606.3.1.
So what that tells me, a bed joint, if I start out at 3/8 and I have to add 1/4, I can go, the maximum is 1/2 inch. That's what this is telling me. Let's go ahead and read those problems. So right now, the minimum thickness, I'll read the problem 113 again. The minimum thickness of head and bed joints in masonry construction, except for the starting course over the foundation, is 3/8 of an inch. If we go down to 114, mortar for use in masonry construction shall not be less than 2 1/4 and not more than how many times the sum of separate volumes. Table R606.2.8. R606, table R606.2.8. Let's see, what is the sum of separate volumes of lime and cement? So if you have an aggregate ratio, not less than 2 1/4 and not more than 3 times the sum of separate volumes of lime if used and cement. So these are mortar proportions. Know that this table exists. The answer in this case is 3 times. That's what you're going to do. Now let's get down to 115. We already read this from 606.3.1, but I'll read the question, then we'll answer it. So what is the maximum thickness of the mortar bed joint in masonry construction, except for the starting course on the foundation? And I mentioned before, 3/8, that was the answer to this problem. 113 was 3/8 of an inch. But if you're going to add 1/8 of an inch for tolerance, what they're asking for is what's the maximum allowable thickness. It's actually 1/2 inch. So if you're on a job site, you need to know 3/8 to 1/2 inch. Kind of hard to maintain that perfection when you're doing this kind of work, but yeah, whatever. I guess after some experience, it's easy. All right, 116. Solid masonry shall have what? So now I want to be clear. We're dealing with solid masonry construction. So if you're doing R606.321, let's read that. R606.321, solid masonry. Solid masonry units shall be laid with full head and bed joints, and all interior vertical joints that are designed to receive mortar shall be filled. So if you're doing solid, it all has to be filled. Solid blocks. All right, grout shall be placed not more than how long after water's been added. So I was just doing a job. This is kind of interesting. It's worth pointing out. This is interesting. Okay, so had a company come out to the job site pouring concrete. They did sidewalks and engineered sidewalks. I mean, crazy high level of quality were necessary. The truck is batched out in the parking lot and then delayed for 2.5 hours before coming in. They poured, it was just too hot. And it started spalling within like 3 weeks, 4 weeks, something like that. So it demonstrates that when you are mixing your concrete, there is a time that it's useful. You go past that time, it's not going to have the proper strength. So I'm just using that as an example. Let's read 606.3.5.1. 606.3.5.1 right here. Grout placement. Grout shall be a plastic mix suitable for pumping without segregation of the constituents and shall be mixed thoroughly. Grout shall be placed by pumping or by an approved alternate and not more than 1.5 hours after water has been added. So you're allowed 90 minutes. You go past 90 minutes, can't do it. So just keep that in mind when you're using it. All right, 118. Prior to grouting, mortar shall be removed from the grout space if it projects more than how far into that space? R606.3.5.2. All right, 606.3.5.2. Provision shall be made for cleaning the space to be grouted. Mortar that projects more than 1/2 inch into the grout space is required to be removed. Okay? So 1/2 inch is the magic number there. All right, 119. Where required by the building official, cleanouts shall be provided in the bottom course of masonry for each grout pour with a grout pour height exceeding what? So you need to have actual cleanouts within, whatever you're pouring into if you're more than a certain height. Now, what's that height? 606.3.5.2. So let's go to 606.3.5.2, read this next highlighted section. Where required by the building official, cleanouts shall be provided in the bottom course of masonry for each grout pour where the grout pour exceeds a height of 64 inches. So 64 inches is your answer there. 120, masonry cells containing reinforcement shall be what?
606.3.5.3. And this is probably obvious, but let's go to 606.353. Construction requirements for grouted masonry construction shall be as follows. Masonry shall be built to preserve the unobstructed vertical continuity of the sills or spaces to be filled. In partially filled construction, cross webs forming cells to be filled shall be full bedded mortar to prevent leakage of grout. Head and end joints shall be solidly filled with mortar for a distance from the face of the wall or unit not less than the thickness of the longitudinal, blah, 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 blah. Okay, so that is item 1. Let's see here. We need 353. 353. So, and you can go through. Cells containing reinforcement shall be filled solidly with grout. And since I don't think I referenced this one, let's read this as well. The thickness of grout or mortar between masonry units and reinforcement shall be not less than 1/4 inch, except that 1/4 inch, blah, blah, blah. So, know the highlighted things. These are important. But the point is, it comes down to it needs to be solidly filled where there's reinforcement. So solidly filled. That's the answer. All right, 121. The minimum thickness of masonry bearing walls more than 1 story shall be what? What's the minimum thickness of masonry bearing walls supporting more than 1 story? R606.4.1. R606.4.1. The minimum thickness of masonry bearing walls more than 1 story high shall be 8 inches. So the answer there is 8 inches. Let's go ahead and select that. Solid masonry walls under 9 feet of 1-story dwellings and garages shall not be less than what thickness? So how thin can you get away with? Let's go to R606.4.1. Again, continuing the highlighting area here. Solid masonry walls of 1-story dwellings and garages shall be not less than 6 inches thick. We're not greater than 9 feet. That's the other part of the problem. So 6 inches is the answer. So you can get away with masonry walls of as little as 6 inches. All right, gable end construction. Now this is kind of a trick question. You need to think about this. But it's something realistic and something you could see. For gable end construction for 1-story dwellings, the maximum height of 6-inch thick solid masonry walls is permitted to be what? Now we already read in problem 122 that 6 inches is allowed up to 9 feet, right? Well, here's a little caveat, an exemption of sorts they give you. What it says is 9 feet in height, provided that where gable construction is used, an additional 6 feet is permitted. So technically speaking, on the gable end of a wall, gable end of a structure, where you have 6-inch walls, it's only supporting, basically a roof, you can actually go 15 feet because it's 9 plus 6 is 15 feet. 9 feet for the structure, 6 feet additional for that attic, your gable end side. All right, 124. A solid grouted bearing masonry wall that is 8 inches thick is allowed without supports for how far? Table 606.6.4. I'll go ahead and read that. Table 606.6.4 right here. Spacing of lateral support for masonry walls. So the maximum wall length to thickness or wall height to thickness ratio is what this comes down to. So the solid or solid grouted, that's what we're talking about in problem 124. It's a bearing wall. And the question is, you don't have a support on this. And this is wall length, okay, wall length, not wall height, wall length. And if you have 8 inches thick, 8-inch thick, in this case, based on this, you can have 20 times 8 or 160 inches without lateral support on that wall. So the answer here is 160 inches. All right, 125. What percent of the units at the intersection for horizontal lateral support of a masonry wall shall be laid in an overlapping masonry bonding pattern with the wall? Okay, so, in like a lateral support or another wall, what do you have to overlap for a horizontal lateral support? Basically what it comes down to. Let's look at 606.6.4.1.1. 606.6.4.1.1 bonding pattern. 50% of the units at the intersection shall be laid in an overlapping, having a bearing of not less than 3 inches. Overlapping masonry bonding pattern with an alternate unit having a bearing of not less than 3 inches. Okay, so there you go. It's 50% is what it is.
You have to have that cross weave for your lateral support. All right, 126. Interior non-load bearing walls shall be anchored at their intersections with vertical intervals of not more than what? So we're still in the, the masonry area. I probably needed to have some description there. But let's look at our 606.6.4.1. Our 606.6.4.1. So 606.4.1. 606.4.1. Okay. What do we got here? 606. Why can't I find this? 606.6.4.1. All right, well, it should have been .2, okay? So, look, I want to be clear, this isn't perfect. I've said that before. I made a mistake in the reference. But just look at the vicinity. It's going to be there. Be a simple typo. You'll figure it out. So let's look at 606.6.4.1. It should be 2. Interior non-load bearing walls shall be anchored at their intersections at vertical intervals of not more than 16 inches. Now, 16 inches comes up a lot. You'll see that all over the place dealing with masonry-related work. If you're in doubt, choose 16 inches. Usually, you're going to be safe. All right, metal reinforcement for interior non-loading bearing walls can be which of the following? So 606.6.4.1.2, same thing that we just read. So let's see what we have here. Metal reinforcement. Okay, let's just continue reading on with joint reinforcement of not less than 9 gauge or 1/4 inch galvanized mesh hardware. So 1/4 inch galvanized mesh hardware is the answer right there. Let's go to 128. The unsupported height of masonry piers shall not exceed their least dimension times what values? Let's go to 606.7. 606.7. The unsupported height of masonry piers shall not exceed 10 times their least dimensions. So in the last section, when we were dealing with concrete, I mentioned this number 10. When you're confused or in doubt, select 10 when they're talking about a ratio for height. Usually, that's the one they're going to pick. All right, the required capping of hollow piers shall be of solid masonry concrete that is how thick? So if you have a hollow pier, you need a cap on it. How thick do you have to make that cap? 606.7.1. Hollow piers shall be capped with 4 inches of solid masonry or concrete, a masonry cap block, or shall have cavities of the top course filled. So the answer is 4 inches in this case, 4 inches. All right, let's jump into number 30, 130. Masonry elements for townhouses and seismic design category C areas shall have horizontal reinforcement consisting of not less than what spacing? All right, let's go to our 606.12.2.2.3, parenthesis 1. That's a heck of a reference. 606.12.2.2.3, parenthesis 1 right here. So, once again, I've mentioned this before, but always have to go back because these are specific. So, reinforcement requirements there. Then you come up here, design of elements not part of the lateral force resistance. Then you come up here, seismic design category C, townhouses. So, to get all the problems right, you have to know what the subsection is, the subsection, then the section here. But let's go ahead and read this. Horizontal reinforcement. Horizontal joint reinforcement shall consist of not less than 2 longitudinal W1.7 wires, spaced not more than 16 inches, blah, 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 blah. So there's 16 inches again and 16 inches again. And like I said before, 16 inches comes up all the time when you're dealing with masonry. So when in doubt, use 16 inches. All right, 131. A sill plate shall be connected to masonry walls with at least a 1/2 inch bolt embedded how deep? Now, I mentioned before in the other video, part 2 video, I mentioned 7 inches for embedding in concrete. Masonry walls, a little bit different. So let's go ahead and look at this. Let's read the reference, 606.11, parenthesis 1. So figure 606.11, parenthesis 1 right here. And if you look here, 1/2 inch bolt at 8 foot on center embedded in 4 inches. So it says 4 inches, 4 inches, 4 inches, 4 inches, 4 inches. You see it coming up all over the place. So it is 4 inches, not 7 inches as though it was concrete. All right, 172 or 132. Half-inch reinforcing bars shall be lapped. How long in reinforced grouted masonry construction in seismic design category C? Let's look at figure 606.11.2. And if you look here, it gives you the lapping value right here. The lap value is 40 times your diameter. So in this case, keep in mind half-inch or number 4 rebar multiplied by that lapping, the 40 times diameter value, that's scalar. So 40 times half is 20, right? 20 inches. So the amount those pieces of rebar have to lap is 20 inches. That's what you have. All right, 133, bonding wall ties for multiple Wythe masonry shall be not less than one metal tie for how many square feet with a maximum vertical distance between ties not to exceed 24 inches. A lot of details in that. Let's dissect this. R606.13.12 or .2.1. Let's see, where are we at? R606.13. Let me jump over here. There we go. 13.2.1. So let's read. Bonding with wall ties. Ties embedded in the horizontal mortar joints. There should not be less than one metal tie for each 4.5 square feet. So right there. So if you're doing bonding ties, you need one every 4.5 square feet to meet that question. Let's go to 134. What is the maximum horizontal reinforcement for glass unit masonry panels, little glass blocks? What are you going to use here? 607.9. 607.9. So I'm going to read this here. Glass unit masonry panels shall have horizontal joint reinforcement, space not greater than 16 inches. There it is again, that magic number, 16 inches. Comes up all the time. All right, 135. The IRC allows concrete wall construction up to how high without a registered design professional stamp? Let's look at 608.2 and figure that out. 608.2. Construction of exterior concrete walls. Buildings shall not exceed 35 feet in mean roof height or 2 stories in height above grade without having a registered design professional. So we'll just go ahead and go to, what I say there, 35 feet, right? 35 feet. Magic number, 35. All right, 136. The maximum slump for exterior concrete wall construction shall not exceed what? So the slump is, you're going to measure it, pour it in the little cone, pull it up, it's going to spread. What is the maximum slump spread? So let's go to 608.5.1.4. 608.5.1.4 right here. Slump of concrete placed in removable form shall not exceed 6 inches. So the answer there is 6 inches. All right, concrete cast in removable forms for concrete wall construction shall have how much concrete cover over number 6 and larger rebar for areas exposed to weather or earth? So let's look at 608.5.4.1. 608.5.4.1. All right, support and end cover. So this is reinforcement installation details. Let's read this. Minimum cover for reinforcement in concrete cast in removable forms that will be exposed to the earth or weather shall be 1.5 inches for number 5 bars and smaller, and 2 inches for number 6 and larger. Okay? So keep that in mind that there's a difference here. And there's several factors. One's the size of your rebar. One's whether it's exposed to weather. One's if it's exposed or laid right against like a dirt form type thing. So there's a lot of variables that run into this. So you have to look at those details very carefully when you're reading that question on your ICC exam. All right, 138. This is what it says. For an end wall length of 45 feet and a sidewall length of 60 feet and a roof slope of 12.12 and a basic wind speed exposure of 120 B, what is the unreduced length of a solid wall required in each exterior end wall for when perpendicular to the ridge for a one-story structure? It's a lot of details. Let's look at table R608.7.1.1 parenthesis 1. There we go. So unreduced length, you are of solid wall required in each exterior end wall. So what you're dealing with is a basic wind speed here, exposure 120B. Have a 12-12 pitch, end wall length of 45 and 60. So I took these right out. Now, if you're going to be less than that, read the table here in terms of interpolation allowances, but I took this right off the chart. It's 24.71. That's the number here that we're looking at for your UR. All right, 139. This is it, folks. Wrapping up. What is the embedded length of 1/2 inch connecting bolt within concrete in the wood frame roof to top of concrete wall? So let's look at these figures, 608.9 parenthesis 9 and figure 608.9 parenthesis 10. So I'll jump over and check that out. Let's roll over here and see what we got. All right, 608.7, I got a ways to go here. Okay, here we go. So 7 inches, figure 608.9. Let's see, 608.99. Guess I can use this one in 10. So 7 inches, magic number there. Just go ahead and read these sections to understand this. 7 inches there. So magic number is 7 inches. Hey, thanks for watching part 3. This was for that practice exam number 2 that I made. I'll get a couple more tests out when I have time, but I appreciate you watching this. Really hope it's beneficial. Thanks for your time, and good luck on your test.